Mohga, and today we're going to be talking about electromotive and potential difference. In this lesson, we're going to explain what is an electromotive force, know that the electromotive force, or the EMF, is measured in volts, understand what's potential difference, and describe the use of voltmeters. Let's start. Electromotive force is a name given to the potential difference of the power source in a circuit. So when we're looking at a battery or any power source, I'm seeing what is the potential difference between both terminals in that power source. So it's the electrical work done by a source in moving a unit charge around a complete circuit. Since it measures the voltage, then we measure it in volts. On the other hand, the potential difference is the work done by a unit charge passing through the components themselves. So when I am looking at the source itself, I say this is an electromotive force and it's measured in volts. When I'm looking at the components, so I'm seeing how it's going to go around the circuit, the bulb, the resistor, then we're talking about potential difference. Both of them are measured in volts, but electromotive forces for the supply, power supply, and potential differences for the components. So as electrons flow through a cell, they gain energy. Like in this 12-volt cell, every coulomb of charge passing through it gives it 12 joules of energy. As electrons flow through the circuit, they lose energy. Why? Because this energy is used up by the components, used up by the wire as heat, so it gets used up and it loses energy. So it left the cell as 12-volt cell, and it is transferred as 12 joules of energy through wires and components in the circuit to be used up. How to measure the potential difference? We measure the potential difference using a device known as a voltmeter. The voltmeter has to be set in parallel, as you can see here in the picture. If you remember in the last lesson, we said that the ammeter, which measures current, is used in series. The voltmeter is used in parallel. We put it parallel to the component which we want to measure the potential difference of. Okay? So a voltmeter can be connected to 2 points in a circuit before and after the component itself. Analog voltmeters could have a problem, as there could be parallax error if I'm not reading perpendicularly. There could be a zero error if it did not start exactly at 0. So always double check where the marker was in the beginning, and always double check when you're reading that you're reading perpendicularly to avoid parallax error and to avoid zero error. Digital voltmeters are a bit more accurate, as they give you the exact number and you can specifically know the value. However, just like digital ammeters, they may display a flicker back and forth, making it hard for you to judge the exact value. So they should be checked for zero error to make sure that they started exactly at 0. That's all for today's lesson. Please let me know if you have any questions. Have a lovely day.